Welcome to my YouTube channel. Today I'm going to be lecturing on programming with C++, and today's topic will be on types and declarations. Let's get into it. Our main objective at the end of the lesson is to be introduced to C++ types, learn the fundamental types such as booleans, character types, integer types, floating points, voids, and sizes. We'll also be introduced to declarations, learn the structure of declarations, declaring multiple names, scope, and initialization. Let's get into the main deal now. Now, when we say a data type in C++ programming language, it refers to the various forms data can be represented in a language. These examples include the integer, the float, the boolean, and the string and character, and so on and so forth. We have categories of data types, which include the integral types. That's what we'll be dealing with today. That's the integer, character, and boolean. The integral and floating point types, which are also known as the arithmetic types. The enumeration and classes are also called the user-defined types. I'll be treating that in my next video, so stay tuned. And also the fundamental types such as pointers and references. They are all called the built-in types. Now, these data types have data sets. It specifies the range of values a data type is composed of. As I said earlier, each data type has its data set. So now when we talk about the data sets for each data type, the integer data type has is a set of whole numbers, whereas the floating point data type is composed of two, the float and the double. So the float is a set of decimal numbers with single precision, while the double is a set of decimal numbers with double precision. Now we have the character data type, which is a set of letters, numbers, and symbols. And the Boolean data type, which is the true or false. This is the logic operation. We also have the string data type, which is just a combination of characters. Now we have data sizes. So this specifies the amount of memory a data is allocated in a data type. So the amount of memory a data has in a data type. Now each data type has a data size, and we use the size of keyword. So the size of keyword is together, it's not separated, determines the size of fundamental data type. So in your coding, we use size of keywords to determine the size of the fundamental data types. Now, as I said earlier, the sizes are the memory or the amount of memory a data is allocated in a data type. So for integer, it uses 4 bytes. So a memory, remember bytes are memory, so it uses 4 bytes. Floating point, for float, it uses 4 bytes as well, but for double it uses 8 bytes, because double takes a decimal numbers with double precision, so it takes a lot of memory. That's why it has the 8 byte. Now a character, it uses just 1 byte because it's just a letter or a number, or symbols. Boolean uses just 1 byte. That's the true or false, yes or no. It can't be true and false, no. It's just one. And the string uses 32 bytes because it's a combination of characters. It takes a lot of space to run. Now, with the integer data type, this is an example. We know an integer is a set of positive or negative whole numbers. So the positive in programming, positive integers do not have to have a plus sign in front of them. No comments are used within an integer, and comments are used for separating items in a list. Now this is basic So, I'm going to be delving into the practical session after I'm done with the theory part. So, let's just take note of this code and we'll get into it later on. So, as I said earlier in my previous video, the int is a data type, the x is the identifier or the variable name, the equal to sign, which I'll be teaching you later, is the assignment operator. The 25 is the value being assigned to the variable x, and the semicolon is a terminator. So this is for the integer type. We use 25 because integers are positive and negative whole numbers. So we chose a positive integer like 25. And as you can see, there was no positive sign in front of the 25. That's why we say in programming, the positive integers do not have to have a plus sign in front of. Even in mathematics, we don't put the positive sign in front of the figure. If it's positive, you leave it just as it is. Now, the floating point type, it represents floating point numbers. That's decimal numbers. It has three types. Actually, it's the float and double, and it has a long. Now, the float is just a single precision. Double is a double precision. So the single precision, threshold is the amount of decimal places it takes is 6 or 7. For the double is 15, and the long double is an extended precision. So this is how we program a float. I will teach you guys more on this practical session later in my practical session. So as we see, this is float. Not this is float, so it takes a single precision. That's why it has just 12.72. This is a float data type or float number. Now the double, we can see it takes a lot of decimal places after the decimal point is there. Now we move on to the Boolean data type. This is used to express results of logical operations, as I said earlier. In programming, we don't write the full word as Boolean, we just write it as bool. It has two values, either a true or false, or a yes or no. Now, the true value or the true represents 1 or yes, and the false represents 0 or no. This is also an example of a Boolean program using C++. So bool, and this is case, C++ is case sensitive. So we start the letter, the beginning of the letter with a small letter, then we leave no space, then we bring the capital R. This is not wrong, it's actually programming. So the data type, the identifier or the variable name, the assignment operator, and the value. With the character data type is the smallest integral data type. Each character is enclosed in single quotes. Take note of this. Each character is enclosed in single quotes. Some of the values belonging now in character data type. When you want to program a character data type using C++, you don't use the full word as character, but you shorten it to be the cha or car. Yes, so some of the values belonging to car data type are A0, and all of these. But as you see, they are in single quotes. Without a single quote, you might get an error. Now, a blank space is a character and it's written as this, just a blank space, with a space left between the single quotes. So this is an example of a character data type, a single quotes for the M. And note, character cannot take a word as a character, so it takes only a symbol or a letter. Now, the string data type is a programmer-defined type supplied in the standard library. I said earlier in my previous video what the standard library does. So the string data type is a programmer defined type. So the person or the programmer defines this type and it's applied in the standard library. The sequence of zero or more characters is a sequence of zero or more characters, so the combination of characters, and it's enclosed in double quotation marks. So when character is enclosed in a single quote, the string character or the string data type is enclosed in a double quote. Now the now and now is a string with no characters. Each character has relative position in string. So this is also a program or a C++ program of a string data type, double quotes note. Now when we come to void, we say void signifies the absence of information. Syntactically, a fundamental data type is also a fundamental data type. It can be used only as part of a more complicated type. It's mostly used in functions, and that I'll be treating it in my next video. This is also a way to define or declare void using C++ program. Now we come to unsigned and signed. They are also data types or types, and they are both type modifiers. So for the signed, it has both positive and negative value, and the unsigned only represents non-negative values. So take note, the sign has both positive and negative values, but the unsigned restricts the programmer to only non-negative values. That's for positive values. So this is how we declare or program a signed type modifier. And this is an unsigned type. Note I said positive value, so we use the integer data type with it. It's a modifier, so it modifies the properties of the variable x, and the x should be declared as, we need to know the type the x is. That's why we brought the int with it and we brought the unsigned. So it's a modifier that's modifying the variable x, which is an integer. Yes. Now we have other fundamental types. We have the short that has 2 bytes, that's a memory. We have the long, that's a 4 bytes, and the long that has a 8 bytes. Now we'll be going to composite types. They are also types of C++. We have the pointers and arrays. We have the reference types that will be treated in my next videos. We also have user-defined types. As the name goes, user-defined. So the user defines this type. It's not actually inside a standard library. The user defines it. So the data structures and classes, for instance, are user-defined types. Enumeration, that's representing specific sets of values. And yeah, that's all about it. So when we want to declare, now we are in for declaration. When we want to declare a variable or declaring multiple names, we say it's used to declare several names in a single declaration. The declaration uses comma for separation, mostly done for similar data type. So when you want to declare and you want to use a comma for separation, you use a comma only when the variables have similar data types. So when variables have varying data type and you use a comma, you actually get an error. So you use the comma during declaration when the variables or the identifiers have similar data types. So this is basically what they were saying. So we can see the identifiers x and y are having the same data type or similar data type. So instead of repeating the lines of code, you can just input one data type, then you use a comma to separate them. Now we delve into the scope. C++ has a scope, the local and the global scope. that's what I'll be treating today. And we also have the class scope, the namespace scope, the statement scope. So for the global scope, is sorry, it is inputs or programmed outside the local scope. So the local scope is actually the whatever is programmed inside the int main. As I said earlier, is the int main is where data is entered. So that's the local scope, and the global scope is outside of the int main, which is the local scope, but it can be accessed from inside. But the local scope, whatever is inside the local scope, cannot be accessed by the global scope. But whatever is inside the global scope can be accessed by what is inside the local scope. Now, declaration. An identifier or a name, a variable name, must be declared before being used in C++ program. So if you want to, let's say we are finding the area of a circle, and we just start by saying pi r squared, and we want it to display for us. We can't just input pi r squared without letting the program or the computer know what the pi is, the r is. So we declare it, we make it known to the computer. So what before in declaration, the structure is the data type, then the identifier or the variable name, how you want to describe the work, or how you the variable you want to use. So this informs the compiler what kind of entity the identifier refers to. Like as we have here, so the char, the string, the int, and the double, they are all data types. And the ch, the s, the count, and the pi, they are the identifiers. So without or declaring the word ch, the compiler wouldn't know what entity or what kind of entity the ch refers to, whether it's a string or an integer or a character. So we need to declare it. Let us know what type or what data type it is, so it can run what you instruct it to do. Now we can see there is const. I didn't talk about that, but I'm going to talk about it. So the const data type actually is it implies, since pi is a constant, we use the word or the data type const. Now const is used to make pi a constant number. It doesn't change. So in your program you can't modify the pi because you brought the type const. And that keyword const, when it's brought, the variable value cannot be changed unless you use another type like static cast, and I'll be treating that later. So the const, then the double, we bring the other data type because the const is modifying the pi. As you said earlier, it's a type modifier. It modifies the identifier or the variable name pi. So this is the basic structure of a declaration. So declaring a variable, we say we declare ch. We want to make it a character. As I said, we don't write character in full, just char, then ch, then you terminate. Let's say you want to make s a string, so string s, then you terminate. Now, initialization. Initialization determines the initial value of an object. It can be used to modify value of. And initialization can use one of four syntactic styles. So it can use one of four syntactic styles. So this is one. The first one is one style we can use to initialize a variable. The second, the third, the fourth. but we are going to be dealing with the third. So now in initialization, this is where we assign the value to the variable. As I was saying earlier, we assign the value to the variable. So the value 25 is the initial value for the variable or the identifier age, and integer is the positive or negative whole number. So age is definitely an integer. It can be float or decimal because age isn't a decimal number. So the data type. So in declaring or initializing a variable, the structure is the data type, the identifier or the variable name, the assignment operator, the value, and you terminate. So here the data type is int, the identifier is age, the assignment operator, then the value you want it to have, then you terminate. The second one, the data type is char, the identifier or variable name, gender, the assignment operator, and the value. And note we put it in a single quote because character deals with single quotes. So this is basically all what we have on the theory. Let's dive into the practical session. Welcome back. So when you open any C++ software, this is the base. It gives you the basic structure of C++, but this isn't what we're going to be doing today. So let's clean this side off. Yeah. Now we begin. We said we have 6 data types: the integer, float, double, string, character. Alright, so we dive into it. With the integer data type, it's just int. We don't write the full word as integer. In programming, we use int. The identifier is a variable name you give. That's the name you want it to have. So let's say int score, or let's make it age as it was. Then you terminate as it is. Then let's declare, or let's use another data type. So let's say char food. Now before I move on to the next data type, you realize we said the character deals with just letters or symbols, but one may ask, why am I writing food? Well, what I meant by the letters and symbols were when you are assigning the value to the data type. That's when you use the rule. You follow the rule as in the single quotes, then the letter or the single quotes and the symbol. But when you are declaring a variable, the food is a variable name, so there isn't any mistake in it. So we declare the next data type, let's say string, and let's just say name. Then we have the float. Then floats, let's say the weight of an object, so weight. Then we also have the double, and let's just say kinetic energy. Remember, C++ is case sensitive. No spacing, a small letter begins. Then finally the boolean. So bool, let's say it's raining. So these are the data types we have in C++. We have more, as I said, but this is what I'll be taking you through today. And this is basically declaring a variable. So what I've done, I've declared a variable, and I said earlier that in declaring a variable, the structure is the data type, the variable name, then you terminate. So in declaring a variable, there is no assigning of value in it. It's just the data type, the variable name or the identifier, then you terminate. So in declaring a variable, you're just telling the compiler that this identifier refers to this, it belongs to this, or it is this. So you make the compiler aware of what age is made of or refers to. You make it known to the compiler. So it recognizes age when you are using it in your programs or in your codes. Now, one thing about declaration and initialization is that when you declare a variable and you output, you aren't going to get any results. Let's try it. So it compiles, then it outputs. As I said, you aren't going to get any results because you just told it that um it should recognize this variable name or identifier for you, but I didn't ask it to display anything to it. Now let's dive into the initialization process. So in initializing a value, we need the assignment operator, and age is definitely a positive integer, so let's give it a positive integer like 44. Now this assignment operator here isn't equal to sign in C++ program. When you want to use this equal to sign is a double assignment operator. So the double equal give you equal to sign or the equal to. But when you use just one, it's just when you use just one, it's just the assignment operator. You're assigning a value to it. You're initializing the variable. So the 44 becomes the age or the variable's initial value. Now with the child food, let's just say assignment operator, then your single quotes, remember? So your single quotes, then a variable. You can also use a symbol, but let's just use a letter. Now the string is a combination of characters, so it just double quotes, then character. So let me use my name, Deborah. The weight, the floats is a decimal number with a single precision. So we're going to use 12.76. And the kinetic energy is a double. Let's use 13.8786, just any number. Then it's raining. That's a true. Now, if you could remember, I said earlier that the boolean, the true represents a 1 or a yes, and the false represents a 0 or a no. So if I'm to tell the compiler to output, let's say, the boolean figure, because if you initialize it now and you run it, nothing will out process. So if I'm to tell the compiler to output something now using the boolean data type, and I use the word true, it isn't going to give me true, it's going to give me 1, because some C++ software has some limits. So instead of using true, it will represent the true with 1, and it isn't wrong because true can be represented as 1 or a yes, and false a 0 or a no. So this is basically how to declare and initialize a variable. let's go into let me output or tell the compiler to display something. So as you know, you use a cout. Let's say we want to display age, so cout, please enter your age. And yeah, now please enter your age. Yeah, so as of now, one may ask, why did I bring the age down here? So this is basically telling the compiler that we receive the input of the user, then what we've initialized here, that's what we assign to the um to what we want this to be displayed. So it's just like saying please enter, or let me rather make it, well, so let's say, since I've already initialized the value, let me change it to your age is, sorry, so this is quite good. So we are telling the compiler that it should display your age is 44. So the age, instead of putting 44 here, we put the age. We can't just write 44 right here. It wouldn't work. And we can't also bring the value 44 here because that wasn't what was declared. It was the variable name or the identifier age that was declared. So, and that was the variable name was what was initialized. So the 44 cannot be put here or represented here. So we use the age to represent the value 44 because now it has the value 44, or 44 has been initialized or assigned to it. So when we output, we're going to get your age is 44. As we see over here, your age is 44. We can work same for all the data type. So let's say cout. Let's say your favorite food is, sorry, your favorite food is, then don't forget, you don't bring the data type, you bring the identifier, what you declared and what you assign the value to. So your age is, then you output, then cout, let's say your name is, then name, cout, sorry, cout, the weight is, or let me make the name a bit more nicer. So let's say you are, instead of your name is, to change the, yeah, then the weight is, so weight, and cout, the kinetic energy, the kinetic energy is, so you can just leave a space for that. Then case sensitive for this, so kinetic energy, now I said for the case sensitive is when you're declaring a variable, or when you're asking the compiler to display something for you that you do not use, or that side doesn't affect the case. So you can actually space and make the kinetic energy here capitalize, the K here capital, and it wouldn't affect anything. But in declaring the variable, that's where the case sensitive issue comes up. So here we can ask the question, is it raining? Then we leave a space. Then here we input is raining. Don't forget to bring back your operator when you're done. So let's run this to see what we will get. As you see, your age is 44, your favorite food is A. We placed a single quote bar, it came normal. That's why. Your name, you are Deborah, the weight is 12.6, this, the kinetic energy is this, and is it raining? Now we see that here it's, instead of true, it's giving us a 1, but it isn't a mistake. As I said, the true represents a 1 or a yes, the false represents a no or a 0. So when you have the 1, it's just the limit of the software, so it's actually correct, it's actually representing true. Thank you all for watching. If you have any question, you can drop it down in the comments section. Don't forget to like and subscribe, and don't forget to turn on the notification button to be notified when I upload a video. Stay tuned for my next video. See you all. Bye.